Morning. Today's case study video is heat conduction in composite wall. This is the mechanical engineering apparatus. You know what is meant by conduction? Ask the question. What is conduction?
What is conduction?
Conduction is nothing but it is a heat transfer mode which is passing from one end to other end by way of molecules. This is the conduction. Here also in this apparatus, heat conduction in composite wall. Anybody ask composite?
So what are the components?
In composite wall means two or more elements is joined together is composite. If two elements or more elements are available, that is being composites. Okay. In composite wall, here three layers of materials are arranged in series. If you heated one end, the other end will be heated automatically. In between, two elements will be located. Okay. Actually, three elements will be there. If you heat the first element, third element will be heated automatically. Okay. That is the purpose of composite wall. Composite means more, two or more. Wall means let's say vertical arrangement. That is the composite. Here, in this apparatus, what we are considering is what are the elements available means temperature indicator. We can rotate the temperature from 0 to 6. We can add 1, 2, 3, 4, 5, 6 like that. We can add a heat. To increase the heat, what will happen in temperature? And this is the ammeter. Ammeter is the current measuring equipment. How much current will be consumed by the equipment? That is the ammeter. Voltmeter, how much voltage is required? That is the voltmeter. Here heater, demaster, and this is the rotometer. Rotometer is the in composite wall. If we can go to the thermal engineering, there is a formula is available. That is L by K. Suppose 3 layers are available means L1 by K1 A1 plus L2 by K2 A2 plus L3 by K3 A3. If you add all these three components, we can calculate the total resistance offered by the metal is calculated. That is the resistance. So, in heat transfer mode, you can calculate the heat transfer formula is Q equal to HA del T. HA means, H means heat transfer coefficient, A means area, del T is the temperature difference between first element and the last element. This is the main formula. The unit is watt per meter square Kelvin. So we can calculate how much heat is transferred. So you ask in composite wall, in all the industry, they are suppose the particular equipment is want to store more or withstand high temperature means we can use composite wall. Where composite indicates lightweight and but the strength is more. Instead of using steel, if you use composite means the capacity is more and the weight also reduced. That is the main use of the composite wall. Okay. Here what are H I already told H, small h is the heat transfer coefficient. Heat transfer coefficient vary with the different element. Suppose copper means it has different heat transfer coefficient. Steel means different heat transfer coefficient. Copper means different coefficient. So all the materials having different heat transfer coefficient. According to the heat transfer coefficient, the three layers will be joined together. We can calculate the what is the overall heat transfer coefficient we can calculate. That is H. Suppose in some other textbooks it is calculated by U. U also known as overall heat transfer. H also heat transfer coefficient for the individual. If you add all the three heat transfer coefficients, we can calculate what is the overall heat transfer coefficient. A means area, that is surface area. Surface area means length into breadth. T means temperature, T means temperature difference. What is the first temperature? What is the third temperature? To calculate T3 minus T1, we can calculate the temperature difference. So, what is the formula? Q equal to HA del T. Then interact with V, if you have You ask any advantages?
Sir, what are advantages, sir?
Advantages. Thank you.